Purple Comet ends tomorrow and teams are fumbling these 5 problems right now. We are speedrunning all 5 in one video to save your score. Let's go. First up, circular combinatorics. Question: how many ways can 6 students be seated around a circular table if 2 specific students refuse to sit next to each other? Steps. First, let's find the total ways to seat 6 people in a circle. The formula is n-1 factorial. 6 to 1 equals 5. Total circular arrangements. 5 factorial gives us 120 total combinations. 5 equals 120. Calculate total ways. Now, let's group the 2 haters together as one single block to see how many ways they do sit together. 5 to 1 equals 4. Treat beefing students as one block. 4 factorial is 24 arrangements. 4 equals 24 arrangements with them together. But wait, they can swap seats with each other, so we multiply by 2. 24 asterisk 2 equals 48. Multiply by 2 for internal swap pi and g. Finally, subtract the bad arrangements from our total. 120 to 48. Subtract bad from total. Boom. 120 to 48 equals 72. Final answer. Next. Infinite nested roots. Looks terrifying, but it's basically a cheat code once you spot the pattern. Solve for x given that square root, x plus square root, x plus square root, x plus, equals 5. Steps. Since the entire infinite string of roots equals 5, the nested part inside is also exactly equal to 5. Square root, x plus 5, equals 5. Substitute 5 for the infinite nest. To get rid of the root, we square both sides. Square root, x plus 5, squared equals 5 squared. Square both sides. The square root and the square cancel out beautifully. X plus 5 equals 25. Simplify. Now just subtract 5 from both sides to isolate x. X plus 5 to 5 equals 25 to 5. Subtract 5. Cancel those 5s. X plus 5, 5 equals 20. Simplify. And x equals 20. Easiest points of your life. X equals 20. Final answer. Problem 3. Number theory. We need the sum of all positive integers less than 100 that have exactly 3 divisors. Question. Find the sum of all positive integers less than 100 that have exactly 3 positive divisors. Steps. Here is the golden rule you need to memorize. Numbers with exactly 3 divisors are always squares of prime numbers. P squared 100. Identify the prime square pattern. So let's list our prime numbers under 10, since 10 squared is 100. Primes, 2, 3, 5, 7. List relevant primes. Square every single one of them. 2 squared, 3 squared, 5 squared, 7 squared. Square the primes. Which gives us 4, 9, 25, and 49. Squares, 4, 9, 25, 49. Calculate the squares. The problem asks for their sum, so let's add them all together. 4 plus 9 plus 25 plus 49 equals sum. Add the numbers. 87 is the magic number. Sum equals 87. Final answer. Problem 4. An algebra puzzle. Don't waste time solving a massive system of equations, look for the visual pattern. Question, let f, x, equals x squared plus bx plus c. If f1 equals 4, f2 equals 9, and f3 equals 16, what is the steps? Notice anything about our outputs? 4, 9, and 16. They are all perfect squares. 4, 9, 16. Spot the perfect squares. Let's rewrite them as 2 squared, 3 squared, and 4 squared. 2 squared, 3 squared, 4 squared. Rewrite as squares. See the link? The base of the square is always exactly 1 more than the input. f(x) equals x plus 1 squared. Find the function pattern. Let's test it. If we plug in 1, 1 plus 1 squared is 4. It works. f(1) equals 1 plus 1 squared equals 4. Verify the function. Now, plug in 10 for our target value. f(10) equals 10 plus 1 squared. Substitute x equals 10. 10 plus 1 is 11, and 11 squared is 121. 11 squared equals 121. Final answer. Final boss. Combinatorics. We need 3-digit numbers where the digits add up to exactly 10. Question: how many 3-digit numbers have the property that the sum of their digits is exactly 10? Steps. Let's represent our hundreds, tens, and units places as variables h, t, and u. H plus t plus u equals 10. Set up the equation. The hundreds digit must be at least 1, so let's shift it down to 0 by subtracting 1 from both sides. H, 1, plus t plus u equals 9. Shift hundreds digit. Now we use the stars and bars method. 9 items going into 3 bins. 9 plus 3 to 1, choose 3 to 1. Stars and bars formula. That simplifies down to 11 choose 2. 11 choose 2 equals 11 asterisk 10 slash 2. Simplify combination. 110 divided by 2 is 55. 110 slash 2 equals 55. Calculate base total. But wait. Our hundreds digit can't be 10, which happens if t and u are 0 in our shift. We must subtract that one impossible case. 55 to 1. Subtract the h equals 10 edge case. 54 valid numbers. You just crushed the purple comet practice. Subscribe for more. Total equals 54. Final answer.